So next we're going to talk about the units we're going to use for working with atoms. The reason we have our own units, though, is because we need units for counting huge numbers. So why is this? Well, let's talk about a unit you probably know. A dozen is a term you've used. If Darius has 1 dozen eggs, we know that means he has 12 eggs. So in addition to numbers like this, like a dozen or a gross, we also have numbers for counting gigantic numbers. So specifically, scientists use a term called the mole, which represents 6.02214 times 10 to the 23rd of anything. So as you might imagine, that's a pretty big number. So for example, a mole of marbles is 6.02214 times 10 to the 23rd marbles. That's enough marbles that we could definitely fill up the earth and still have plenty of leftover marbles. A mole of sand grains is 6.02214 times 10 to the 23rd sand grains. As we know from the beginning of the chapter, there aren't even that many sand grains on Earth, even as tiny as a sand grain is. So we also call this number Avogadro's number. So I mentioned that in case you see that reference somewhere. It has to do with the discovery of the relationship that led to this number being useful. But for this class, we're going to use a slightly shortened version of this. You can also get this number a little bit longer. But 6.022 times 10 to the 23rd will be good enough for solving problems in this class. I strongly recommend you memorize this number. You will use it a whole lot. But if you do forget it, I do have it on the equation sheet I give you on each of your quizzes and exams, and obviously you could look it up as well. But you'll use it a reasonable amount. So let's do something with it now. So how do I use this mole? Why is this number useful to me? So converting using moles is going to work the same as other conversion factors. Some students have trouble with it, though, because the number is so big that it looks weird. Like, it doesn't feel as bad to convert like a dozen of something as 12, whereas this number can feel weird. So let's take an example with our dozen first. So if you had 3 dozen eggs, you would multiply it by the fraction 12 eggs over 1 dozen eggs. Because remember that 12 of something equals 1 dozen of it. That means we can write that as a fraction, and it's the same as multiplying by 1, since the top and the bottom are actually the same thing. So we'll say eggs in this case, and eggs. So this means the dozen eggs cancels, and we're left with just eggs. So 3 times 12 is 36. So what does this look like with a mole and when it comes up to this? So let's say we had 2 moles of atoms. Well, we can multiply that by 6.022 times 10 to the 23rd divided by 1 mole of atoms. And when you do that, the moles of atoms cancel. We multiply and we get 1.20 times 10 to the 24th atoms. On the other hand, you can go the other way as well. So if you started with 3.50 times 10 to the 23rd atoms and multiply it by the fact that 1 mole of atoms is divided by 6.022 times 10 to the 23rd atoms is the same thing, the atoms would cancel and you'd be left with 0.581 moles of atoms. So we're working with these numbers because many times you're going to be dealing with multiple moles of atoms. Even when you're doing something small, like you're measuring something on a weighing plate, if you measure out some salt to use for some chemical reaction, you may have an entire mole. Or even if you don't have an entire mole, maybe you've got a quarter of a mole. You will have lots and lots of atoms and even very tiny amounts of something. So that's why we're going to use the word mole a lot, because it would be unwieldy to say, well, how much salt should I measure out? You should measure out 1 times 10 to the 23rd atoms of salt. That becomes really unwieldy. Moles make a lot more sense for us to work with. So let's do a practice problem using this conversion. So I want you to try solving out how many atoms of gold would there be in 1.50 moles of gold. So now hopefully you've worked it. Let's take a look. So if I have 1.5 moles of gold, I'm going to write gold as Au. That's its atomic symbol. And what we know is that for every mole of gold, there's going to be 6.022 times 10 to the 23rd atoms of gold. So if we do that math, the moles cancel, and we are left with 9.03 times 10 to the 23rd atoms of gold. I also want to point something out. So the unit is called a mole. We sometimes abbreviate it as MOL. And that seems kind of strange in some ways. You're like, you abbreviated it 1 letter. Yes, we did. So just to know, when we say MOLE or MOL, these are not different things. It's not like, wait, Dr. Leslie, you went from moles with an E to mole without an E. Why did you do that? There's no particular reason. I've seen it. It gets used both ways. Just to know these are the same things. It's not that you're missing something we didn't tell you about. Let's do one more practice problem now. So I want you to try going the other way. So how many moles of gold are there in 2.45 times 10 to the 23rd atoms of gold? Now that you've solved it, hopefully, let's take a look at it. So if I have 2.45 times 10 to the 23rd gold atoms, that should be a U. What I know is that for every 6.022 times 10 to the 23rd atoms that I had, I would have 1 mole of those gold atoms. So my atoms would cancel. That's gold moles. There we go. That's fine. I meant to put atoms of gold down here. So we do that. The atoms cancel. We're left with moles. And then we do the multiplication problem. And we have 3 sig figs, so we have 0.407 moles of gold. There we go. And I don't mean to switch between the moles and with E and without, but it's just kind of automatic, something that I've done for a long time. So that's 2 examples of how we use the mole of gold and how we're able to do calculations with that. In the next section, we're going to look at how to connect this now with the information of the periodic table. Why is it I said you're going to look up atomic mass a lot, and how you can actually use moles more usefully. So that's what's coming up next.